Hello, my name is Abraham, and with my group, we are going to explain the derivatives rules. We have the power rule, the constant multiple rule, the sum rule, the difference rule, the product rule, the quotient rule, the chain rule, and the power rule with the chain rule. So I hope you enjoy it. We are going to explain each one of those rules, and here we come. Well, my name is Abraham, and now we have the other one, the derivatives rules. We have the chain rule and the constant multiple rule. First, I'm going to start with the constant multiple rule. We have the formula right here. You can see it. What it says is that if you multiply your function fx by a constant c, you can pull out c unchanged when differentiating. So let's take a look. We have here the constant multiple rule. Well, here we have the exercise, the gx equal 5x to the third power. It's very simple what we're going to do. First, we have the constant, it's 5, the number 5, we can see it right here. Here we have it, let me, here. So we will multiply the number 5 by the power of x. In this case, we have x to the third power. And the rule is super simple. You just have to pull out the constant and differentiate the power. So we are going to first pull out the constant, we have it right here, and differentiate the power, we have it right here. Then first step is to spot the constant. We already did it, it's right here, the constant is 5. Here the 5 doesn't change with x, so we can treat it like a tag along. Then we're going to differentiate the power. The general power rule says that we have to take this number right here, that it's the third power, the power, and we will have to take it down next to the 3. We have it right here, as you can see. We're going to take that 3 next to the x, and then we have to take the 3 we had in the power and do a difference and take the 3 and minus 1, and it will get us this number that is the number 2. So x to the third power differentiate, it will give us this number completely, that is the 3x to the second power. Now we have the 5 that is the constant and the power that was differentiated, and we just need now to multiply the 3x to the second power to the constant that is 5. So here we have the 5 multiplied by the 3x squared, and it will get us this number, this result. It's 15x to the second power, and that's the result we needed. We use the formula right here. You have the formula, as you can see it, and that's it for the constant multiple rule. Well, now we have the chain rule. It's very simple. We have it right here, as you can see it. Here we have the formula. So in words, it says that to differentiate the f of the gx, we need to differentiate the outer f, this one, as if its input were a plain variable, giving f prime g, and then we need to multiply this result by the derivative of the our inner function, this one. The inner function, we know it's gx, we have it right here, and this is the outer function, f prime. So then we need to derive the gx, and it will give us the g prime x, and then multiply it by the outer function, the f prime g we have. Now we have the exercise on the chain rule. We have it right here. So what are we seeing? We have fx equals sin, then open parentheses, we have 3x to the second power, or 3x squared plus 2, close parentheses. So first, we have to separate this operation because we are doing chain rule. So we have an inner part, is this one, and we have an outer part, it's this one, the sin. Here you can see it, outer function, inner function. Then, so This is a function inside a function. We call that a composite function. Then I'm gonna tell you the step by step of this exercise. First, you have to name the inner function. We have it right here. It's u. I put it u. You can see it right here. U equal 3x squared plus 2. Then we have to name our other function. So it will be sin of u, as you can see it right here. Now what we're going to do, we see sin of u, so if you know u, you plug it into sin. We know u is 3x squared plus 2, so we have to plug it into sin. Then we have it right here, the complete operation. Sin plug with the u, that is 3x squared plus 2. Then we need to differentiate the inner part. So what are we going to do? We are going to differentiate it. The derivative of 3x2 it's 6x. 6x. And then we have that we have a constant right here, it's 2, and the derivative of a constant is 0. So the u prime of x will be this 6x, as you can see it right here. Now we did the differentiation of the inner part. We have that 3x squared plus 2 is 6x, and then we need to do the differentiation of the outer part as if u were the variable. So what are we going to do? We know that the derivative of sin is cos. So we have it right here. We are going to change the sin right here to the cos right here. Why? Because we are doing f prime of x. So now we have to derivate the sin, and it will give us the cos we have right here. And then multiply it by u, that is 3x squared plus 2, and multiply all that equation to the 6x that was the u prime. Why? Because the formula says that we need that the derivative of f of u of x is equal to the f prime of u of x multiplied by u prime of x. So we already did the f prime. We have it right here, f prime. The derivative of sin is cos, and we have u right here, u of x. We have it. We said it at the beginning. It's our inner function called u, and then multiply it by u prime x. That is the derivative of u. We did it right here. Is 6x, and this is our final answer. We just need to solve this. So we are going to get that 6x and put it at the other side with the cos, and it will get us the 6x cos of 3x squared plus 2, and that's the final answer.
Okay, now we are going to explain the sum rule and the product rule. The sum rule, the definition says that the derivative of the sum of two functions is the sum of their derivatives. Uh, Here is the formula. The formula says if h of x equals f of x plus g of x, the h prime of x equals f prime of x plus g prime of x. Now we have one example of this. In this example, says it's f of x equals x squared plus sine of x. And the first step is identify the two functions. U u equals x squared, and the other is sine of x. The next step is find the derivatives. U prime is 2x, and the ub prime equals cosine of x. and is the result is this: f prime of x equals 2x plus cosine x, and that's it. And now we are going to explain the product rule. In the product rule says that the derivative of the product of two functions is the first function times the derivative of the second plus the second function times the derivative of the first. This is the formula. The formula says that if h of x equals f of x times g of x, then h prime of x equals f prime of x times g of x plus f of x times g prime of x. Now we have one example of this, and this it. This example says that f of x equals x squared times cosine of x. The first step is identify the two options. Um, in this case, the u of x equals x squared, and ub of x equals cosine of x. And the second step is find the derivative. The u prime of x equals to x, and the v prime of x equals negative sine of x. The next step is apply the Proctor rule. And it says the f prime of x equals to x times cosine of x minus the x squared times sine of x. And the next step is simplify. Is this step? It says that f prime of x equals to x cosine x minus x squared sine x. And that's it.
Hey, I am Nicolas Niño, and I'm going to show you the power rule with the chain rule and the difference rule. Chain rule combined with the power rule applies when you have a combination of functions raised to a power. Yes, and the difference rule states that if you have the subtractions of two functions, and that is so using the chain rule combined with the power rule is an example. Apply the power rule in the first part. The power rule says d over dx of x to n equals n by x to n minus 1, and this is the first part. 4 by 3 by the inside function and the exponent minus 1. This is the power rule. Apply the chain rule by multiplying by the derivative of the inside the function. 4 by 3 by the inside function by the derivative of the inside function. That is the chain rule. Is the same to say other function by the derivative of the inside function. So derivative of the other function, yes. And the different rules is basically the different rules. You have to derivate the both functions, and the sign is minus, yes. This is an example: 3x 2 minus 2x plus 1 equals 6x. That is the derivative of 3x 2 minus 2. That is the derivative of the 2x plus 1, and that is all.
uh, the power ruling. The power ruling is basic rule in calculus that helps use find the derivative of function where the variable is raised to a power. The formula of the power rule d over dx parents x derived to the power of n parents quiz nx derived to the power n mean 1. The formula. Step number 1, identify the exponent. We see that the exponent is 4, so we will apply the power rule. Step number 1, f prime parents x parents square 4 multiplied x derived to the power of 4 million 1, using the power rule. Using the power rule. Step 2. Step 2. Simplify the exponent. um, f prime parents x parents square 4 multiplied x the different or the power to the power of 3. Step 3. Step 3. Step 3. Step 3. Step 3. F prime parents x parents square 4x3 final hours. Final hours. Final hours. The quick rules. The quick rules is used to find the degree of fusion, that is fraction, when of fusion is divided by another. A quick rule formula. D over dx parent, fx over gx parent over gx d over the dx parent, fx parent minion fx d over dx parent gx parent over g parents gx the rate to the power of 2. The example, f prime x quarter x derived the to power of 2 over x plus 1. Step 1, plug into the formula f prime parents x parents square um, parents x plus 1 x plus 1 parents to x parents minus parents x relevant to the power of 2 parent 1 parent over parent x x plus 1 parents relevant to the power of 2. um, step 2. Step 2. Step 2, apply the equation rule. Plug everything in the formula. F prime. F prime o f x water parents x plus 1 parents multiplied parents 2x parents minions parents x quartered parents multiplied parents 1 parents over parents x plus 1 derived to the power of 2. Step 3. Step 3. Step 3, expanding and simplify. Expand and simplify. X x 1 x plus 1 times 2x water 2x 2x square plus 2x x square times 1 quarter x square. Step step number 4, prime of x squared x squared plus 2x parents x plus 1 parents derived to the power of 2